This presentation is on the egg drop project. My name is Mary Lee.
I'm Grady Alley.
Vanessa Morgan.
And I'm Sean O'Hare. So to begin this presentation, I'm going to speak about how we use the engineering design process in the creation of our egg drop device. So we started out by defining the problem with constraints, which is the first step of the EDP. We were to create a free-falling reusable device that would safely land an egg from a high drop. We had 50 note cards and one roll of tape to use, and the assembly time for this project was 30 minutes maximum. We started by generating ideas through a brainstorming process. Some of our ideas were a parachute using straws in a triangular fashion to absorb the impact of the ground. And another option was to add a cushion to the egg compartment to soften the impact of the ground. We then went through a process where we selected an idea based on proposals from individuals of our group. We decided on a pyramid shape, a triangular basket for the inner section that held the egg, and we also made a change to the process and to our device where we lengthened the legs of the device for greater energy absorption.
The next steps of the engineering design process that we went through was researching the specific idea that we had. We found other examples of egg drops based on energy absorption and dissipation, and we then researched why our initial idea would work and how it actually functions in the process of energy dissipation. The next step was to begin prototyping, which each member of the team designed a different variation of the initial concept, and together we found the best one that would work that saved the egg from utter destruction. The final step of the engineering design process for our assignment was to create a set of instructions that would allow another team or team member, not part of our team, to create the egg drop device that we initially created. So we did that by following along the construction process, and I actually took pictures of each step of the construction phase, and then we built the instructions as a team, and then we refined the instructions based off of real-world applications and physics.
How we managed our time. This project was completed using a combined effort by everyone in the group. All 4 team members were involved in the brainstorming process. 1 member volunteered to build and prototype the initial design. All 4 members worked on the instruction assignment. 2 members were tasked with writing the tech report, in which all 4 members edited the report to create a single unified voice. Then all 4 members recorded the analysis of the initial test. Finally, 1 member was responsible for outside testing of the project.
How we wrote our instructions was we had 2 people build the prototype while the other 2 people would write down the steps of the construction process. And when we were done with the prototype, the people that were building the prototype would briefly read through the instructions, and we would discuss among ourselves to fix up the instructions. And when we all agree with our instructions, we had one of our team members give the instructions to someone else instead of us to test it out. And when the person that tested our instructions is done, we would have them give us the feedback on our instructions, and we would incorporate their feedback into our instructions. And when we were done, we gave our instructions to another group. For our team schedule, we met on October 22nd to 8 to 9:40 a.m. For that day, our goal was to get basic ideas for our prototypes down. On October 24th, we at 8 to 9:40 a.m., which was an in-class work day, we reserved we reserved that day to do building and testing our designs. And on October 25th, from 9 to 11 a.m., on that day, the purpose of the schedule meeting was to work on the other assignments due on this project.
The build team's comments were, the first one was that we didn't list that we needed a pencil in our materials, and this was actually against the assignment rules anyways. We didn't realize that we couldn't put the pencil in there, so that was fair. We also didn't say that we should standardize the pencil size. This led to uneven sizes of tubes, which ended in mistakes that I'll talk about later. In step 5, they said that we should clarify what we meant by tips. I think we could maybe add the extra wording of ends there to kind of point at maybe what we meant with tips of the rods. And then the last thing that they said was to make instructions more clear when explaining the math. They said they didn't need all the rods. They had 12 extra, where we definitely should have used all 30, so I think something needed to be changed there. So some improvements that need to be made to our project. Like I said, we need to be a little more clear with our instructions. We didn't really define our lengths or our diameters, I guess, as well as we should have. We used some terms that could have been misconstrued a little one way or the other. And then as well, we need to be a little more specific about how to build the project. Our build team ended up with a little bit of a lopsided build, and we're not sure whether that was due to our wording or what, but something needs to get changed in order to ensure that the final build is quality and sturdy.
And from all of us to you, thanks for watching.